my pig dissecting video. Let's begin. Just kidding. It's not dead. It's not dead. Hey guys, it's me, Danpreet, the most funniest guy alive, obviously. So this is my Genius Hour project on dark matter, and may I just say, this is absolutely torture, pain, and suffering to do. It's funny as it may not exist, so I may have just wasted my entire time doing this project, months of research, just to come to the conclusion that I wasted my stupid time. But for the sake of it, let's just say it was very fun, and I definitely learned a lot, and my brain is definitely not fried after doing this. So let's begin. Woo! And let's just do a quick trivia game before we start. So who's the most hottest student alive? 3, 2, 1. Correct! You are so smart. Oh my god, sir. You have such a bright future ahead of you. I can feel it. So for this presentation, I will be breaking up into 3 stations. You have the origination of dark matter, the proof of existence of dark matter, and then detecting dark matter. Let's get into it.
What? You there? I am back from the dead, and I am here to tell you about what dark matter is. So, what is dark matter? Wait, I'm a pig. Dark matter exists in our universe, with dark matter accounting for 80% of its mass, which humans are unable to see. Many astrophysicists refer to matter as glue that holds galaxies together, since one of its claimed qualities is it attracts objects. Many people are unaware that dark matter exists because one of its features is that it does not release light or energy and doesn't absorb any electromagnetic radiation such as X-rays and radio waves. So what is it made of? Currently, no one knows what dark matter is made of, but scientists were able to say that it is made of neutrinos and other candidates being WIMPs and axions. The reason for this assumption that it is made of neutrinos is because of its properties, that the particles are similar to dark matter's characteristics, as it does not emit light and its mass is very light. The second candidate being Exion is a good possibility as well due to the properties. Exion is said to be a force that can bind quarks within protons and neutrons together. It also is similar to neutrinos where it reacts very weakly with light, which connects with the property of dark matter where it does not emit light or energy. WIMPs, which is weakly interacting massive particles, is the greatest candidate as one of its properties is that it is able to pass through solid matter due to it now being able to experience electromagnetic interactions with which is similar to one of dark matter's qualities. So, let's get into the origination of dark matter. Oh my god. Mickey, what are you doing to her? What happened to PDA in the household? Oh my god, that is disgusting. But hey, let's just go back in time near the Big Bang. Let's not worry about what Mickey is doing. He's a teenager. Hello. So there's two possible. I have many possible originations things that I found during my research, but I decided to choose the two main ones that I felt were more interesting and you guys could connect to. But the rest are on my website if you guys want to check it out. But we'll begin.
Hello, I am Ferb. I killed my brother Phineas. I don't like him. I now own the show. So, let me begin. A recent study claims that early in the cosmos there was a mysterious kick that generated more matter than antimatter, implying an imbalance between the two. Dark matter may have formed as a result of this imbalance. The reason for this is that there was a major symmetry breaking event that resulted in matter defeating antimatter. But then there was a mysterious event that caused dark matter to gain prominence. It's possible that the two processes are linked, and that the presence of dark matter was due to the presence of more matter than antimatter. Let me get to the second point. I'm taking over because my I don't know what to say. I'm Pango from Club Penguin. Bang 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 bang.
Scientists say that dark matter must have existed beforehand because if dark matter truly was an effect of the Big Bang, then a direct signal of dark matter should have been detected in numerous particle experiments. So researchers, oh my god, my English is so bad, guys, essentially look back during the cosmic microwave background, which was before the Big Bang, and the universe at this time would have never be able to be hot enough to reach the Big Bang, and everything was spatially flat. This is then explained through the cosmological inflation, which was the time where the universe exponentially expanded and ended when the Big Bang happened.
However, dark matter does not fit with this and the research essentially said dark matter must have existed beforehand and suggests that during cosmic inflation, there were particles being produced such as scalars which have no spin or inner structure. One found so far is the Higgs boson. Higgs boson, but dark matter can also fall into this category.
Bang, bang. Give me this. Give me this. Hello.
Wow, you guys must be very bored right now. I can still imagine Mr. Ferguson yawning and everyone else yawning. I'm so sorry, but you guys must bear the pain for a few more minutes because I had to deal with this for months. So now let's get into the proof. We can look back in time near the 1950s to 60s when astronomers first began measuring the rotations of spherical galaxies, and they predicted that stars near the galaxy core, where visible matter is the most concentrated, will travel faster than stars at the edge. Instead, stars at the galaxy's edge had the same rotational velocity as stars towards the core, proving that galaxies and galaxy clusters may contain such unseen kind of matter, which allows for the gravitational forces to observe and behave alike. Look at me speaking so many facts. I'm so smart. Using telescopes such as galactic clusters, scientists hoped to find pools of hot gas that had gone through undetected and could account for the mass being attributed to dark matter. They found vast clouds of superheated gas, but it was not enough to account for the disappearances in mass. From measurements of hot gas, I farted. Smell it. Superheated gas, but it was not enough to account for the disappearance in mass. From measurements of hot gas pressures in galaxy clusters, there must have been 5 to 6 times as much dark matter as all the stars and gas we can detect, or else the cluster's gravity would not be able to keep the hot gas from
9.81 is gravity. Gravity.
To keep the second proof really simple because we're running out of time. This is sun. This is the planet Urano. It rotates around the sun. The gravitational force keeps the velocity going. Right. The more gravitational force, the better, greater speed. Scientists were looking if they looked at one of the stars well as it went away, and assuming that there's no more gravitational force pulling on it, it should slow down. But even after it actually increased speed. This is theoretically possible as there was nothing there to increase the velocity speed, but however, it increased speed. So there's assumption that it was dark matter that played a role into this. Really quick demonstration, but it makes sense. Look at Doggo eating. Boring. Look at him run with the pig. He's running. No! Come back! Come back! Give me back my pig. I have a project to do. I don't know why I'm including him. Get back! Get back! Get back! Get back! Get back! Oh no! Get back! Get back! I need my pig! I need my pig! Please! Please get back! Get back! Oh my god! Give me back my pig! I can't keep restarting this! He's not giving it back! I got you! You win, you evil monster. You win. You can keep the pig.
Hey, yo, I'm from Toronto, yo. I know the slang terms, yo. Yo, da da da.
I'm the cool kid. Look at me. Look at me. So detecting dark matter, which is my third point. I have to go really fast because my doggy took away my pig. So gravitational lensing is essentially the bending such distort of light when it goes through an interaction with large amounts of mass. This is because of its gravitational pull causing it to distort or bend. By dark matter acting as a hidden mass, astronomers are able to infer that there could be black matter as there is a bending of light occurring, but nothing can be seen that would cause it to do such a thing. He's back with the peace offering. No, give it, please. Please, 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 please. You menace to society. You menace. You must feel so proud, don't you? You doggy. Oh, I have to get that back. 1 second. Alright, so the LHC, which is another company that helps detect dark matter. So their approach of finding dark matter is through direct detection experiments where they take a suitably large detector, put in an environment that is very quiet and free from the background influences that can mimic the dark matter signal, and then they just simply watch the detector and wait for the nucleus of the atom to suddenly zip off. The whole idea of this is that the dark matter particle came along and it hit the nucleus, which resulted in it to zip off. They do this in real life where they place them in deep underground chambers away from anything that can interfere, such as electromagnetic signals from your phone or cosmic rays. An example of this can be seen in this image. And another detector is the XENON 1T,
and that can be found on my website.
From my experiment, I was actually able to get dark matter. I know, I'm so smart that I was able. I'm kidding. What I actually did was just get water because matter can be solid, liquid, or gas. So I have water over here, and I put some black ink in it, and there you go, dark matter.
I'm just kidding. I actually have a whole different experiment. So what this experiment is a wine glass and a random document I found. It demonstrates how gravitational lensing works. Essentially, when a glass goes over the picture, in this case, it distorts the light. This distorts the light. This is similar to how astronomers come to possibly know of dark matter as the presence of matter or energy density, if you wish to say, can curve the space-time and the path of the light ray will be detected. And this similar concept can be applied applied to dark matter as if it goes in the way of the light. By seeing if there's a deflection and there's nothing visible there could be dark matter. So just in this case, it's just replicating how the light is it's getting distorted, as you can see, which is really cool. Like if you look, the light is getting distorted. There you go. That's just a small example of how gravitational lensing works. Thank you guys for listening to my presentation. I hope you guys enjoyed it. So before we go, we will just see Mickey Mouse doing slow dance real quick.
When marimba rhythms start to play, dance with me, make me sway. Like a lazy ocean hugs the shore, hold me close, sway me more. Like a flower bending in the breeze, bend with me, sway with me. When you dance, you have to stay with me, stay with me, sway with me. Other dancers may be on the floor, dear, but my eyes will see only you. Only you have that magic technique. When we sway, I go.
Thank you. Have a great time.